Okay, we're recording. Okay, for Spencer and McGill, I just realized that I had not turned it on, and I'm gonna, anyway. So here we go. Sorry about that. I'm gonna do screen shares, and if you can get in and help me remember if you're not seeing something, that help me remember that maybe I don't have something in sync. So I'm gonna do my best to keep stuff in sync for you. This is Durable King, Samson Community College, ELC 215, the electrical maintenance for automation systems. And this is January 14th on Thursday. This is our second night. And we are looking at the electrical schematic for station 1. That schematic, I'm going to do a screen share. For you guys that are remote doing this, let me change to show you where the schematic is on the Moodle, on the front end on the Moodle page. If I go back to here. Now let me resync it again. Every time I change screens, I have to resync it. So or it'll stay on the previous screen. That's there we go. Now, those of you out there watching, you should see the welcome mat now. So the way you can see this schematic from where you are on your phone or your computer is you go to the main front end of ELC 215 and you scroll down and you'll see right in here, electrical schematics for the automation system stations 1 through 6. You click on that and the diagram will come up. Yeah, but it's going to be the diagram for all of them, and you just start at the beginning and scroll to whatever station that we're dealing with. I'll go ahead and click it so you can see. When you do it, that window pops up and over here, and there it is, and you can maximize. And you can hit the plus button. And there you are. All of that is right there available, right there in Moodle, that you can see the schematics in Moodle. And there they are. That's it. So I did get all that done this afternoon, so you won't get behind. So it's all there for you, McGill and Spencer. Okay. So I'm going to go back to my regular. I can actually just teach right from that. It's the same thing. So anyway, we were identifying on station 1. We said that that's 120 volt right over here. And let's make sure that I'm in sync, that I've got it synced again for the schematic. Right there. It will not switch screens unless I tell it to. I found that out the hard way from other students. So we're synced good now. Again, we're going to look at how do we know that this is a switch, and how do we know the difference between a switch and a push button? You see that V in there? The V represents a locking detent on a switch. This is an international IEC symbol that's used if the machines come from Spain, Germany, Italy, anywhere other than the U.S. that come from Japan, South America, Canada. Everybody in the world is using IEC symbols. Schindler, you're using these symbols. These are the same symbol sets that Schindler uses because they're a European company. European company. Here's Victor. Hey, man. Excuse me, man. Yes, sir. Y'all hear that? What you're looking at looks almost identical to what Shimmer used. I'm going to make a statement, and this is not an overstatement. If you hear me good, I'm telling you the truth. When you take this class, you will learn the international standards that are used everywhere in the world but here. And they're used in the U.S. if anybody adopts. If they choose to use international symbols, then they're using them. But most of them are going to use NEMA. NEMA is the U.S. symbols that are actually easier to read. And it's what we use in motor control. It's the standard symbols that are U.S. based. And none of them are hard to read. So you got the U.S. NEMA symbols that you learn in the ELC 117, and then you have the IEC symbols you're using in here. Now you learn IEC in ELC 117 in chapter 2, you're going to see, you'll see columns that will show the NEMAs and the IEC side by side in chapter 2. So those of you taking motor controls now, in chapter 2, you're going to find out that we're going to compare the two systems, and you're going to learn both of them in there, but you're going to use NEMA on a daily basis in there. Even though you'll know the difference between them. You'll have all of that will be right there in chapter 2. They all will be in there. In here, so you're going to get rid of all of them, and you're going to use them a lot. When you finish this class and you finish the motor controls, you will be able to read a schematic from anywhere in the world. Anywhere in the world, and you'll be able to pick it up, and you'll say, well, I know what these symbols are. Because there's not but two sets of symbols in the world that I know of. Now, every now and then, somebody may want to be an oddball and use some odd, weird symbol that ain't standard, and they got a right to do that. But there's not a lot of that going on. There's, for the most part, 98% of the time, it's going to be out of one of them sets. And I've never seen a schematic in my life that I could not read. And I don't care where the machine come from in the world. I ain't seen one yet I couldn't read, kept somebody figured out. And I'm not the hottest engineer in the world by no means, but I ain't kidding you now. You can bring this guy, Victor, you can bring anything you want to right here from that plant, and I would lay $100 bill and I could read it. More than likely. And more than likely, it's very likely I could read it. And it'll help somebody learn how to read it. And it ain't because I'm a hot shot, it's just because I've studied those two systems. And you can do the same thing if you study them thoroughly, I'm sorry. Anyway, so that.
What were you saying the V was? What were you saying the V was? Just push button symbol?
No, the V is a detent. It's a locking mechanism for a switch. So that's the giveaway is this a push button or a switch? The little V symbol means it's a switch. So I'm going to pull up your, well, instead of me switching screens so much, on your study guide, and let me just pull out one that's not filled in. That's your selection. How to select the switch. It's got two names in that box. Right, so if you look on the study guide, that first symbol, where do you see that on there? Y'all found it? Yeah. I mean, there's only one location on the side. I mean, that is like symbol. The symbol that shows those two compounds. Oh, not that. pumping, look, a double contact. Get the labor out. Look, let me get the labor going. We're talking this symbol right here. I'm circling there. It includes two normally up contacts, but an actuator, and the actuator is a locking detent that's a switch. And that's the international symbol for a switch. Like that. Now you can write out some sign of it, that is your selector switch switch. On your symbol guide, it can be simply a selector switch. And it has two normally up contacts. You put two, and then put the end over here for two normally up contacts. We really don't know, if you look right here, on that study guide, we don't really know that that's actually the completion of that switch. We just know it's a selector switch, and you know it's got two normally up contacts, right? So that's all you got to put on there is a selector switch, and it has two normally up contacts. It's hard to show that.
You have to put selector switch, not power.
You can put select switch lines and put it has two normally up contacts. It's a switch. Yeah. If you want to put the power switch, that's fine. But a generic, if you look here, what I've done for you, go all the way to the back page. And I've got a word bank. I've got a word bank in the back. I put a word bank in it to text your current. Right, exactly. So I've done this thing first. I've put power working this stuff and set it up to where it's reasonable work with. I laid out all these gigs and stuff. They didn't have any of that stuff in place. I did conversation there. I bring all that stuff together. This is the schematic, man. They sent me the PDF copies as far as bringing out some of the things that so anyhow, now, if you scroll on down, the next one, if you see where I'm circling right here, the next symbol includes two contacts that are normally what? They're normally closed, they're not normally open. This is the IEC symbol for a normally closed contact. If you notice here, the international schematics, they draw stuff that runs up and down. They don't draw it left and right like we do up here. Their ladders are laying down, and the power goes from the top, and it goes top down, not left right. So if it comes from Europe, Japan, somewhere like that, they lay their ladders, instead of their ladders standing up with the rungs this way, their ladders are laying down, and the rungs are like this. You get the idea? It's like taking a ladder and laying it down, and the rungs are vertical. You know, that's the way the international schematics are done. First place I ever seen stuff like this was Japanese diagrams I worked with in Fujicom. I said, well, why is their ladder laying down? The guy said, that's the Japanese do it that way. And then when I started working in another plant, stuff come from Italy, I said, well, the Italians, they're doing like the Japanese are doing. You know, everything's laying down like that. I said, well, yeah, I found that's the international. When you leave the U.S., that's the way everybody's doing it, you know. So, but you'll get good at all of it. What's your question, Eric? Now, this device name, that's your e-stop. And so it has two normally closed contacts, and you see that little E symbol right there? That little E symbol is actually symbolic of a push button. So that's your IEC symbol. That's your giveaway for push button. And so those two contact blocks with that little E thing there, that's going to be, you can say push button, and it's got two normally closed contacts.
That's the stop one or the emergency stop one?
This is that one. Look right here. Right here, David.
Yeah, I'm saying, is it the stop or the emergency?
That's your e-stop.
Yeah,
That's your emergency stop. The front one is a normally open. That's actually your power switch. That's your power select switch. Power on and off. You know, it's normally open. You cut it off, it's actually open. the E-stop, when you release the E-stop, the contacts are closed, normally closed. Now look, when you hit the E-stop and you slap it like this, you do that, the contacts open. Okay, so that's the difference between an E-stop and a power switch. Power switch is normally open, E-stop is normally closed. That E-stop lets it run until you hit it. It's an easy way for them to go up to something, bam, hit it, and it's going to knock it out. Okay? It's like this there for panic button on the front. Now, the wire numbers that lead into the power switch would be the wire numbers that store that out. The wire numbers are LO1. So the actual wire labels that'll be up here would be a LO1, an NO1 that feed into the power switch. Now between the power switch and the E-stop is LO2 and NO2. That's hot and that's neutral. And you'll only see those is if you actually unbolt the front panel and flip it over and look behind it. That's where you see those numbers behind that panel. You got to take out some Allen screws and flip it over. We'll do that one day and let you check the numbers behind it. That's what they didn't put it on the hinge, which I think is a bad idea. They should have had a hinge flip it up. They didn't think about that too good. Yeah, it could be done. Absolutely, it could be done. Now, well, what happened there? Yeah, I hit the wrong button. Let's see where we are. Let's go. Let's resync here. There we go. So we scroll. So now, and if you look over here, you see that little symbol right there? That's ground. That's a ground symbol. PE means potential earth. And so that ground is connected to the X1 terminal group, terminal 6B. Now, if you're wondering where these are, if you flip in your schematic to the last page in that section, and I'm going to show you where the terminal blocks are. I go small here. Yeah. Now that's page 1. Page 2 shows some other things. Page 3, 4, page 5, 6. Now right there. This shows you a pictorial of the terminal strips. So the X1 terminal group has these terminals that are there. And the X2 group has these, the X4 group has that. When you look at the front of the electrical mesh, you'll see a group, and the groups are labeled. And then some of the groups are hidden, like you got to lay on the back behind the machine and look up in there under this to see one of them. Okay. So, but they're all there. You know, they're all there, and they've done good. They've done good on laying this stuff out. And you get to, let's say when you get to the X3 group. The X3 group is on the front. It's the longest group. And the X3 group has an A at the top and a B row at the bottom. So if you see something labeled in the schematic that says X3 16A, and what it means is this: it's in the X3 group and it's terminal 16A on the top row. And the A and the B's are connected together internally. All of them are connected. They all go vertical. So X316A connects to X316B. You know what I mean? These two connect together. These two connect together. And so the A's and the B's are all hooked together. That's they run through. You know what I mean? They connect together. So whatever wires land into A and whatever's landing into B, they're connected through a little bus clip in there. Okay, that's built in. That makes sense? On the terminal strips. And you have to physically look on the front of them. Whatever wire lands into a terminal this way, it leads correctly coming. Everything is tied hardly to get past the front like that. You look in front of it. And then there are actually some jumper clips that go in that actually make a lot of them common. It might be 10 or 15 of them that are joined together horizontally through a bus clip. And you can see that. I'll show you that, you know, when we get looking a little closer at things. But anyway, so let's go back to the first page. So yeah, we're back to the front. Now let me zoom in here. So the question about your lab sheet. On your lab sheet, it's asking you about the power switch. Is it in the power section or the control section? Now here's the difference between the power section and the control section. The power section is where the power comes into here. It's 120. It feeds in through your power switch, your E-stop, and then it feeds into some more terminal strips and splits to the two power supplies. And these little power supplies are DC power supplies. If you look on the front of any one of these machines, you'll see some little slender black nozzles that are right there. You see them? And they're DC power supplies. I'm going to come around, point to them, and you'll be able to see physically where they are. So they're right here. That's a power supply, that's a nozzle. So they take the 120 coming in, they convert it back to 24 DC. And that's what the solenoid uses, all the sensors use 24 DC. So the generator for that. One of the things that you use exclusively for a conveyor motor is 24 DC conveyor motor. The other one is exclusive for all of the valves and the sensors. And that's the way it goes. One power supply runs the conveyor belt, motor, and the other one runs all of the sensors. And the ELC. Okay? That's the way that works. You see two here. There's two on this one. And there's three on this one. This one has two power supplies for the 24 volt. One of them is for the conveyor motor. The other one runs the same with the valve. And the other one is a 5-volt power supply. 5 volts that runs a 5-volt grid. So the little small power supply that you'll see, if you can come after this one, that other one is small. It's a 5-volt DC. And it runs.
That's the sure one.
So, they all have at least two power supplies in that last one. So here, the 120 volt feeds in LO3, NO3. It feeds in and ground. It feeds in is those power supplies would accept anywhere from 100 to 240 coming in, but we're feeding 120 coming in, and then it produces what? It produces 24 volts DC, and it sends it out to whatever it's tied to. Okay. So right here is where you change over from you change over here from main power to control power. Power section. This is power section. This is control section. Now, so the power supply itself actually functions in the power section and the control section. So that's the only thing that you could say is both power and control on your lab sheet. So when you go to your lab sheet, here, it's really quick and explain so like how this one is structured. So if you go to that's our page 5, you're going to do a B for the power line, C is control, and if it's both, you can put a P slash C. You put C and C, and then you follow. So all we're going to do is identify each component, is it power section or control section or both? Usually a little bit harder, a little bit different. Regular tracing. Well, first of all, let me show you where it goes physically, and then we'll see if we can make some type of that. I never really looked at that one. With the 24, 25, that's the news for them. Right, the 24, 25, it goes over to here. It picks up here.
If I would question like something, example like a shimmer, say you have something from one section, and you say you flip it, yeah, so you quickly flip it. So that's got to be something like that. I'm not thinking. So I'm assuming that means page 2.
We want to see if that line is okay. It's not marked down in the back. That's page 2. But it ain't matched to them. I've often wondered what that means, because I do know the fact that by 24 and 25, it comes off here. It goes through.
I noticed like the first number is different. I noticed that. I cannot figure out how you
And then after that, where you want to.
Yeah. Because generally we have another one. Left. So if they do, then it's really like A1, A2, B.
These numbers up here don't like something. And I have to ask much. It may be to look here because it says here 3.312, that means page 3. 3.1 after that. I got 8. Page 2, page 4, and find out in the reading schematic. When I say it to the top, you can miss something. That's not just put it like
This is something similar. So page that means you're at page 2, and then you go to E with down this side, up and down, and letters. Then you got your numbers. You got an E, and you go to 4. Yeah, we got something missing.
There's something missing. You don't need to go by that here because it's not complicated up that we do. But they're not that much we do. If it goes, y'all missing a page. Copies, when I say to put an automatic finger on the copy, it's missing a page. Let me go to the paper right now. Right now. And you're missing a page. Everybody is missing a page. Look. Got page 1, page 2. And I didn't notice that when I ran on the computer, it accepted the automatic feeder actually takes stuff. So here's the page 3 on the schematic. Page 3. Everybody's missing page 3? Page 6, there's promo one page. Make sure we're on master here. Man, I'm going to start. I don't think. Yeah, I'll be right back. Be right back. Un momento. You go ahead and pull your staple out, and I'll do the staple work, and I'll do the staple. Go get your staple out.
I'm just talking to some of those engineers, see if I can get a that way you can, that way you can have an idea of what's going on. I think the engineers have been down with getting back here, very good. I'm gonna try to keep it.
Yeah, well, see, I asked for stuff before, and they said they couldn't release any of them out. They said they didn't.
Well, see, here's something else. I talked to the police here, Chris, and he said he don't move like that. As long as, you know,
I could ask them when they first said it. I asked them.
well, how did you, what are all the, they drive, they're on the, we're at, yeah, but it's not busy because we still the escalator, we still people can actually put the escalator, so whoever gets what they do, they see who's the back. So that don't make sense, please. Why is it not this? We're giving it to the best.
Like, if you're a fence man.
I thought we were. So I don't, I've never met with any. But it's gonna be gathered up.
They're the meat industry. They make machines. All their shit is.
I like that. We get like, we get to go here, there, and we have a, we can pull up in a PDF, and I'll enter his first thing. For example. So like, say this sort of thing. This is what, this sort of thing. It was done, things that the land that in terminal 4, we have a terminal now. We got, this is already done. So, this is the control, we have this one, have another terminal. And they landed at, say, the like I said, I need to sell, we did that thing, I put it up. All I got out there every week, and it was taking right through that. It was very nice.
I think you are talking about the hard time. Just got to agree to the ball. The hand to me outside before I do it. I got some fingernails. I got this trash can. I'm trying to get trash can. Just put it up here. Yeah, I had short. Double checking when I just made through that there and talking and see that it's something that stay together. That's how we're it. Make a solid now. Are you going that way? If we go in this side, you can see on this side, as you go in that way, it's a label on the line. What I want to do is I want to find a wall and put that stuff on like a piece of firewood down on the wall. That's the main point. In our residential class, that's your list. What happened was, maybe let us come back because of the hurricane. We're going to come back and clean all that up. Man, those plants are still sitting over there just like the world. We got stuff over there. Ain't none of them cleaned up. Oh, wow. We'll hang in this way. Ain't none of them cleaned up. From last semester. Yeah, and the hurricane came, and then it was, you know. I'm just glad it won't work. I'm glad the hurricane didn't hit it. It shut us down that day, but I'm just glad it didn't get up, you know. Just we can all do that.
I just got to north for all the roads that way. I lived like 2 miles from East River. So yeah, we were the river got up to like 29 feet.
Yes. Hey, how you been? Pretty good. You got same class going on? Same good? Good. You see, man, and what do you do? These teaching on the electrical and kind of NCC, it's difficult to find. The divisions, the that's getting the club. It's not a degree. It's if you work with the city, then that time the school system, he goes, what, I've been offered to a full-time curriculum all that. Full-time. And then 3 programs. It's gonna take. Anybody else? How about y'all? Got your own. There we go. 33, right? I put 3 in there. Yeah, I know it's everywhere. Yep, for sure. That'll be now, right. It's a 3 day. That's what we're at. They're supposed to. Okay, so maybe we can get back on track now. End up in that coat. Okay. Let's get this show back on board. Big money. Big money. Okay, so. Now, what did I do with the? I got stuff scrambled up in what happened there. Okay, so back to your lab sheet, the where it's asking you to put a P or a C in or both for a particular component. Page 5 on the lab sheet. Anyhow, let me flip over to the lab paper itself. Now hold on. The power supplies, when you get to those on your lab sheet, they're going to be control and they're going to be power and control, P/C, because they accept main power and then they produce control power. But everything downstream from these is going to be control power. Power, P for power, yes. Exactly. Your control push buttons and LEDs. Now let's move on with that and look. If you scroll over, let me kind of zoom out here. Now the DC power, the 24 volt right here, it feeds over. It's wire number 24 and 25 that feeds the next page. This power supply, it's got 24 volt, and it feeds wire number 26 and 27 that goes to another page. So let's flip over to the very next page and find out what picks up. It's going to be wire 24 and 25 for the next page. And so the next page it picks up here with wire 24 and 25, and 24 is a 24 volt DC, and it actually feeds your push buttons and switches that are labeled, and I'm going to zoom in for you to see what they are. Now, if I scroll up a little bit, just follow through here. Wire number 24 from that power supply on page 1, it feeds in through some terminal strips here, terminal blocks, and it goes through. This is your next symbol. That's going to be a push button, a normally open push button. The little E means it's a push button versus a switch. Now this is a switch over here. It's got that little VD10 on there. That's actually a maintain switch. So here, this push button is the start button. You see here how it's labeled there? That's your start push button. This is the input to the PLC. So when it feeds into the PLC input module, this is the address on the PLC. It's local 1 I data.0. That's the address for the start button. And it's wire number IOO. But getting back to the symbol, look, that's your start button. Now, this one is a normally what? Normally closed. It's also a push button. And what kind of button is it? What's it called? That's your stop push button. It's wire number I01. And there goes the address. You're going to get into addresses in probably a week and a half or so. Local slot 1, I for input, and it's input 1 in slot 1. And anyway, that's the stop button. But the answer to the question on the lab sheet is it says your control push buttons and your LEDs, what are they? Are they in the power section or in the control section? They're in the control section because every one of them are 24 DC. If you look, when you go up top here, the 24 volt DC, the DC bus that feeds all of these, you have all of your switches and all of your buttons and stuff that are there. Your auto manual selector, your reset button, all of those manual controls there, they're all run on 24 volt DC. So they will be considered C for control. And as far as LEDs go, let me zoom out. Where is my, down here at the bottom. Step back. Now, if you notice this, where it says digital inputs, this is to the PLC. This is a PLC input section. And that section accepts your start button, stop button, your auto manual selector, your reset button, and then it starts getting into your sensors, your magnetic read sensors that are mounted on the cylinders. Let's don't get into that. Well, actually, yeah, that's not a question yet in this lab. It's not. We're not there yet. Let's flip over to page 3 in the schematic, and you see some more inputs. You see a pressure sensor, a vacuum sensor, and some more magnetic read sensors on that page. Keep going, the read sensors are what? Yeah, they're normally open. But I'm trying to answer a question here for LEDs. Because it's asking you on the lab paper here, control push buttons and LEDs, what are they? So the LEDs, you got the alarm LED, and then you got the insufficient material LED, the lights. Those, if you go on this page, one of the lights is right there, and it's on page 6. So if I zoom in, you'll also see, if I can find my mouse, when I find my mouse, now look over on, let me get my laser out here. You see over here, these are digital outputs. That's going to be one of your lights on the panel. I'm going to zoom in, but look, there's a 24 volt DC feeding in here. Let me go down some. You see that 24? That 24 feeds in from the first page. It goes into the PLC, into an output section. The 24 volt powers all these outputs. It feeds into here. That's your source. And all of these outputs use that 24 that comes into here. So those are like solenoid valves there. This is one of your LEDs or one of your pilot lights. I'm going to zoom in and you can see which one it is. But the answer to the question would be all of your LEDs, they're also 24 volt DC. This says no material. So that's a stack light. It's output 9 in slot 1, slot 1 output 9, no material. And this is a symbol for an indicator light or LED. It looks like a railroad sign. You see it? But that symbol, if you can also go in your your push buttons and LEDs are going to be secret control. Okay. Now, when you go in your symbol study guide, you can flip over to page. Go to page 3, and you'll see at the bottom, and you can go ahead and put in there a pilot light, or indicator light, or LED light. Okay. Page 3. Page 3 on your symbol study guide. And there's that symbol. Pilot light, indicator light, LED. If you go to the word back, the word that also in there, I put indicator or pilot light. Anything like that is fine. You see it on your symbol guide, study guide. Page 1. Yeah. There's a lot of stuff kind of at one time to be juggling around, but you're knocking more stuff out at one time. But it's better to do it like this now instead of wait some other time to start working on stuff. You're actually making your own stuff out of it. You're answering your own questions. Okay, so. On your lab sheet, the next question, it says about circuit breaker. There's not a circuit breaker on there, so you would put an X in there. And then for motor circuit breaker, there's not one of them, so you put an X in there too. That's probably the ELC itself. There's going to be control. It needs control because let's go back to the PLC and look. This PLC has absolutely no AC involved with no 120 going to it. It's DC going in. It's completely DC power. So let's go back to the main front end where the 24 goes into the PLC. And you'll see that it has to be controlled. Now, right on the front page, this power supply, this little power supply over here, that little black module over there, one of those, it feeds the terminals for the PLC right here. Those are the 3 terminals where the 24 volt goes into the PLC right here. That part number there, the 1796L24ER QB1B, that's the actual part number for the PLC itself. And so this is 24 volts right here coming into it. It's powered by 24 volts. There's no AC whatsoever going to the PLC. So it's completely controlled. Now, these PLCs over here, that we used to use in the summertime program, you put 120 volt in, and they got 120 volt inputs, all the push buttons and everything is AC going in, 120 AC. 120 AC lead, solar noise, the fan, and the lights, and all that, everything on there is 120 AC. There's no DC in that system. So some PLCs are completely AC, some are completely DC. So, that's it has to be right. Some PLCs are on the mixture, like this one right here. This PLC has got AC cards, it's got DC cards. Look here. Just so you know, Don't think that every PLC system is like this. Slot 1 is the AC input, 16 AC inputs. Okay. Slot 2, DC output. Slot 3, DC input. Slot 4, relay output, which actually AC output coming out of the relay. This slot is a temperature sensor input. RCD card coming in from RCD sensor for temperature flow. So it depends on what system and who bought what we want on your system. You can be very particular in the system. You're not going to work with this in here. It's going to be just that system alone. I'm really just going to take the whole spectrum to get all this down. It's better to stick to that. This is the blood rock set up here. They stand for the alarm. And I've used some. I think it was back in the 128 class. I think they did. I thought they did. But anyway, I've got plans to have a ELC 228 an advanced PLC class. It'll have a wider variety of stuff on PLC. A little more stepped up somewhere down the road. But anyway, so on your lab paper, PLC is completely C, and then the industrial communication unit. So what is that? If you look on your lab sheet, the industrial communication unit, if you flip on, it's on page 7. Page 7 in your schematic, it shows an Ethernet module that's behind every station. It's a remote I/O Ethernet module, and that's your communication module that they're referring to. It's completely DC. It'll be page 7. Or it's actually labeled as 6. It sure is. I'm sorry. It's labeled as 6, but in the PDF it says 7 up here. For some reason, you see that there's 6. It is on your paper. It's 6. Now, so on your page 6, I'm going to zoom in. Let's go over to this side where that module is. But look up here. It says 24 volt. The 24 wire 24. It feeds into the communication module, and then the neutral. I mean the common, the 25. It feeds in. So this whole the Ethernet section, all that's 24 volt too. You go in, that's your 24 volt feeding into it, and then your common 25. You see the Ethernet plugs right there. Those are communication connections, Ethernet cable. So behind these units, up under these, you have something called remote I/O, remote input output. The inputs and outputs that are related to this limit switch here it picks up the over the packs there, these sensors, anything back in here on the back end, all of that stuff is put in through remote I/O. And it goes into a module back there, and then those modules connect with the Ethernet cable to it. The front PLC just through an Ethernet cable. So the main PLC has the Ethernet cable that goes from it to the communication module in the back, and then there's another jack here that goes over to the next station. And so if you look here, it's the PLC. Look here, the PLC feeds here from the front of the machine to the back. The back of the machine has this module right here. Let's get my right here where I'm circling, that module is your remote Ethernet communication module that's behind every station that's on the back of the electrical mesh. And it has two Ethernet jacks. One of them comes from the PLC to it. The next one leaves and goes over to the next remote I/O on the next machine. So these data chains through each on the back of it, you got the PLC feeds the remote I/O, and it goes from another Ethernet over to the next station. It goes, they can change around, all of them have double Ethernet cable on jacks on everything. It goes kind of like this. The PLCs have 2 Ethernet jacks on them, and then the remote I/O also has 2 Ethernet jacks. So it's an easy way to go through and daisy chain everything and not have to have a central Ethernet switch that everything goes to like a hub, you know what I mean? See, if you go to some of the closets around the college and open up a closet on some of the hallways, you're going to see a closet slam full of a big old Ethernet switches in there, so where everything goes into a central switch. You know what I mean? This system could have been hooked up that way, but they didn't have to because companies they're including 2 Ethernet jacks on all of their stuff now, which eliminates the need for a central switch. You don't have to, everything doesn't have to go into one big old switch with a lot of jacks on it, you know what I mean? You got 2, so you can feed from some piece of equipment to this and feed from that one to the next piece and just click, click, click. And it functions like a parallel communication bus. It's not like a serial bus, it's basically a parallel communication bus where you can, the very first Ethernet jack on station 1 is free. So I put a switch over here for us. I've got 6 laptops to go in, and I've got one for me. So I've got an Ethernet switch over here, and where you all over there, I've got a jack somewhere you can get to. All that goes into a switch over here. That switch feeds into one port on the first PLC. And that PLC then connects to the remote I/O, and then it goes over here, and it jumps all the way through. So from that one switch, when our 7 laptops hooked up, you can access any PLC you want to at any time from any computer. So this hookup is a parallel Ethernet hookup. You know what I mean? You've got full access to anything in there because of the way it's designed. Does that make sense? So anyway, everything has double Ethernet. I know I ramble on and explain this stuff, but that's your communication unit, and it's for, you put a C in there for control. And then there is no electric access driver. You X that out. There's no robot control unit. You X that out. Okay? So that completes that part. And we're at a good stopping point. Our next part that we'll pick up on Tuesday is going to be this. You go to page 6 in your lab. At the top of 6, it says we're going to start doing some measurements. We're going to measure with a meter. I'm going to show you how to check an input on the PLC and measure it, and then check an output with a meter and measure that. So you'll do the measurements at the top of page 6. That's when we begin to look at how do you physically check things with a meter. So we will go in, say for instance, like right here, where you got a start button at. We're going to let you see how to go put a meter on this terminal right here and check from here to common and measure the input for the start button. When you press start button, you'll check the DC volts coming in, and you'll start to learn how to check your buttons and how to check sensors whenever you're testing, when you're troubleshooting, okay? And you'll also know how to check, say if you're going to check an input, you put the red probe on your meter here on that terminal, and you got to find a common on that input section. The common would be a step back. The common's over here. So if I go over here, for you to check the input for the start button, you put the red probe on your meter here on J137, and then you put the common probe over here on that terminal. It's X3 18B. You see that? That's your common that's for the entire input section. So the black probe on your voltmeter goes here, and then your red probe goes here, J137. It's terminal strip group J1, terminal 37. So how do you find that? You go over to here. It's a piece of cake. Once you get in the swing, you're gonna find out how easy it is. On your terminal strips, where's the J1 at? They didn't draw that on the terminal script. It's supposed to be in there. That terminal, go back, enlarge again. Terminal J1, group J1. J1 32nd. You go to the front. You got to look. You got to stoop up under and you see a J1 group. I'm gonna show you. Look up underneath. You can see that. See the J1 group here. Yeah. This is the J1 group. They didn't put it in a pictorial there. Let me show you also. You know, I'm not telling you the clear here. See J1. That's J1 group. That's J2 group. That's J3 group. That's J4 group. They get the picture. This is one way to see it. Let me show you. J1 group. J1. And the problem is why things are very wide. So the problem is I speed up what I see. See? It's on the bottom side. This is X3 group, everything is X3 something. X3. Once you speed it, 1 times, it's that speed. I'm gonna get you rolling on this electrical and Ronnie Robin that you know what to do. He's like a scooter. You're gonna be rolling and going to buy you a scooter. You know what you see him up over there? Yep. You know what I use to look at them? I got a little mirror in my pocket. A little pocket mirror, and I shoot it up under there. You can see the terminal up under there. You big. Yeah. Yes. Exactly. How we're going to the button and how we're going back to the ELC. That's it. We're going to go for a ride on tonight. Oh. He's identifying everything.
Got to have the power going to your
the button.
Going to your phone. You have to have the turn to make it back to your whenever everything is good and you press it, you have power here to make it go to your
goes into the internal ELC. Yeah. And those little LEDs that are in here, they're all the little lights. They light up. Whatever the address is, the last number and the address, like a dot 0, it'll be LEDs on the front. So if the board there, all the boards are, if you get a light shows up on the, I can't even sleep on it when you get this way. And one of my members, the two, that's right, exactly. But I'll have you whenever there's a problem in there, I'll have you show it with your meters and both meters. Do you have power going to the button? Do you have the leading button?
The first thing you want to check is the button first, right?
Right, right.
More than likely, you're going to check the problem with the button first, right? It's a one is what we actually use most of the time, so that's what we're going to work out. It's for me, this is a big problem with the environment.
Start button. Right,
That's the button.
if you press this button, you're gonna have to have power meters. And if you don't have power meters, you got problems.
But it starts up here. That starts up here and it goes down that way.
Well, you know, the third one is hot. I mean, one side of it comes and opens the top. First,
And it goes one button and it comes back down that way, it's a good problem, get good deal. And it shows up as the LED, and one of these here, it shows up as an LED light. But the utility did it see?
I just didn't know how to read this really good.
You're gonna get real good.
The NEMA is different.
The name is different. It's by AC, it's pure feed, or international. You're gonna be totally, your brain's gonna be saturated with IAC this time. Completely. You like it, it's good. You gotta look a little closer, it's a little more.
Yeah.
It don't really jump out at you like the US stuff does, not quite so easy, but it's still, it ain't hard, it ain't none of it hard, not what I call hard. What we're doing now by you filling out your simple study guide, you're setting up your collection of what is everything, you know? What is everything, and then, then you'll see that there's not so many symbols in the system anyway. And a lot of them repeat, you'll see a whole lot of repeats on this stuff.
Okay.
Yeah.
So we're gonna finish, the practice sheet is gonna be filled out next week.
Yeah, you'll finish that part. We gotta have you you got to physically start measuring the input, measuring output with the meter, and write some numbers down, and then we'll continue with the lab, answer some more questions, and we do a real thorough overview of the schematics of what knowledge. And we'll answer some questions about how many inputs do we have, how many push button inputs do we have, how many switches do we have coming in, how many sensors do we have coming in, like how many limit switches, how many read sensors. Huh?
Can you email me the IUC something again?
The what now?
Remember,
They're motor control, yeah.
I'm gonna look at my email. I remember you said.
Yeah, if you have to race them, it's probably still in there. If you don't have it, let me know. Yeah.
Can you read that?
Yeah, Zuma, yeah.
All right.
Have a good one, Victor. Okay. Interface circuit, thermostat, that's a thermal switch there. Buzzer is telling you what that is. Interface circuit, that's like represents a circuit board. It's not telling you what's in there. And that flip radio and CD player, that's for a vehicle.
Yes.
That's for a vehicle there. Okay. Heater control, you flip on up. Those are speakers. So that's your left and your right audio, stereo speakers, rear door speakers. Yeah.
See, stuff like
That's your stereo. That's your audio there.
once you basically on everything where there's a vehicle or machine industry, there's a European electrical system. The way you read it in the American way.
Right. Actually, you've got international and then you've got USA.
internationally.
You got the NEMA is the USA, and then when you go any other country, it's going to be international, IEC.
You just gotta identify what kind of machine is it. What
That's
is
all.
it? If it's made in USA, then you got it.
It's NEMA.
You already got in your mind what you got.
You already know what you're looking
you're
at.
gonna read.
Right, yeah. And that's the main symbols that we use in motor control. But that book that we hit chapter 2, you're going to see that and this. It's going to be both of them side by side. It's going to say, here's a push button in the US symbol. It goes a push button in the international. And it shows you both of them all the way through. And that's something you need to snap some pictures on your phone and keep them on your phone, and you'll always have them. You'll always have them, because what's in that book matches this when you look at the IEC stuff. Because it compares all of them in chapter 2. You get the whole picture of everything.
Yeah, but I was trying to find some of the symbols that you got on that list. I couldn't find it, and but some of them to me look like, because a motor control it basically is American. So
Well, until you hit chapter 2, let me just show you right here. I'm gonna show you in chapter 2 what So
because I remember.
Are you taking motor controls now or not? No, you're not.
No, I think I took it already.
Let me shut this recording off here. Whoever's watching, I'm gonna cut the recording off. Y'all contact me if you got questions, huh? Your name. Why is it? My computer is getting slow on responding. In a meeting.